Okay, so I wanted to go through some examples with you with pointers. So last week we talked about just all the content in the chapter, and this time I want to focus on some examples, and so you can really see how they work. And so this example, you can see, I'm just going to run it so you can see what it does. It's going to ask how many temperatures you want to enter, so I'll just enter a small number so I don't have to enter a bunch of temperatures. And it'll say enter temperature 1, we'll say 98, 78, 50, or 67, and 68. Okay, and so it's going to tell you the average temperature, 77.75. So I can input, here's the temperatures, it lists the temperatures back off that you entered. Okay, so the reason why I'm showing you this is because it's actually working with pointers. So you can see that here you're actually creating an array, a new array, using whatever number you enter here. So if you enter 4, like I did here, so up here it asked me how many temperatures I wanted. I entered 4, so it created an array of 4. Okay, and then that nums is a pointer to an integer. It's an integer array. And so I can use that nums in 2 different ways. I can use it like this, where I put the asterisk, which means pointer, and then I put parentheses and I put the name plus whatever index value I want. And that's a way to move through it with the pointer. Okay, or I can move through it just like I had before with the name of the array and the index value with the square brackets. So either way is acceptable and they both work. So this is a for loop, and the for loops look exactly the same, where we're going to enter the temperatures, except it moves through them like this when we're taking them with a pointer. And then when I'm printing them out, I'm printing them out with the index value of the array name. So it can be like this, or it can be like this. They're exactly the same. So whichever representation you like better is fine. Does that make sense to everybody? Everybody okay with that? And then the average is just taking the sum divided by how many temperatures you have altogether. And then one important thing that we talked about last week was whenever you create an array, you allocate room for an array, you're putting it on a heap, and when you don't actually delete or deallocate that array, then it takes up room on the heap and it doesn't have any pointer to it anymore. So it causes problems with your program. It can cause it to crash or run out of room, stop saving to the heap. So we call that a memory leak. So we don't want that to happen. So we use this delete whenever we're finished with the array to deallocate it. Now, you could use a smart array, or not a smart pointer, sorry, a smart pointer, so you don't have that problem. But this is just using a regular pointer to an integer. Okay, so if you use a regular pointer, you have to use this delete at the end. If you don't do it, it'll still work, but it might cause a memory leak, and that could cause problems later. Okay, does that make sense, everybody? Okay, I want to take a look at, let's see. This is the same, just another example of the creating an array. So we have here, we have a function called array allocator. And what this is going to do is basically call the array out. You're going to enter the size of the array called number of elements. And then you're going to pass that into the array allocator. And down here, the array allocator is going to create an array of that size, just like you saw in the last example. Okay, and then it's going to return a pointer to that array that it created. So it's a little different because it's just returning a pointer to the array that it created. And then here you can see that then that's saved in a pointer. And then you can use that pointer to actually fill in the values for the array. This one fills them in with just the index value of 0, 1, 2, 3, 4. So like index 0 gets 0, index 1 gets 1, 2 gets 2, 3 gets 3. But you could easily make that a CN and take it from the user with whatever values they want. Okay, and then it just prints them back off right here. But then same thing here, you can actually delete, deallocate the array. Okay, so just make sure if you're using an array and you're using that word new, you're allocating space for an array in the memory heap, that you go ahead and delete that when you're finished. So same thing, except it has a function that does it. Is everybody okay with that? Okay, all right. I wanted to show you, I want to show you this first, this test scores one, because test scores is going to show you the selection sort, which we talked about a couple weeks ago. Selection sort is one of the sorting techniques that we have. We have the bubble sort and the selection sort. So the bubble sort was the slow one that swaps them one by one. the selection sort is a little more efficient, but we didn't spend much time talking about it, so I just wanted to show you it so that you could see it, because the next program I'm going to show you that uses pointers uses that selection sort. And so this test scores asks for how many test scores you want to enter, and it takes that data in here. And then I wanted to kind of walk through this with you. This right here, you should be used to this. This asks for test scores. You have to enter it again as long as it's less than 0. So if you're entering like a negative number in there for a test score, then you'll have to do it again. And so that's always good programming logic to validate the number, make sure that it's actually something that should be in there. So negative numbers shouldn't be in there. So we do this while loop to make sure that we don't get negative numbers in there. So normally you use a while loop or a do while loop. We talked about this, but just kind of reviewing since your exam is coming up. When you use a while loop, you have to ask the question first up here and take in a value and then compare it and then use to see if you need to do it again. Whereas if you were to reformat this, you could reformat this to be a do while loop. And basically what that would do is you would actually do the check at the bottom. The do while loop does the check at the bottom. So in that case, you would ask the question inside the loop. And then when you get to the bottom, you would check to see if you should do it again. The difference is that the way that you write it here with the while loop, you can actually cater your message a little bit, because if you use the do while, you don't know if it's going to happen again. And it just says it one time in the loop. So really you would just put how many test scores will you enter, and it'll just keep repeating that. It won't say that you entered a negative value, because it doesn't know for sure that you've entered a negative value, because you're only doing it in the do while loop one time and it's repeating that. However, this one asks you here, and the only way to get to this loop is if it's a negative number. Okay, so you can actually cater your message and say the number cannot be negative in this case, but it's a little repetitive in that you've already asked the question, and the do while loop saves you from having to ask the question again. So the do while loop cuts down on the number of lines you use, because it wouldn't check to the bottom. It would actually redo this and check at the bottom. And then the while loop checks there. Does everybody understand that, or you want me to show you? I can show you real quick if you want. Yeah. Do you see the difference? See the while loop here? See how the while loop does a C out and a C in, and then it checks to see if it's less than 0. Is everybody with me? Okay, so let's see the difference between that and a do while loop. So I can actually just take this. I like to do this sometimes. When you want your code, you don't want to erase it. You can actually just put a starting multi-line comment here, an end multi-line comment here. That way the code's still there. I didn't erase it. I can put it back in if I want to by taking out that comment. I like to do that when I'm just kind of messing around to show you different things. But you can do that when you're actually trying to see if something in your code isn't working, you think there's a particular section that's not working. Instead of deleting it, so you have to type it back in later, you can always put a multi-line comment on that particular section and bring it back later when you're ready for it. So if a certain section isn't working, just comment it out and bring it back later. That way it's not deleted, it's still in there for later, so I can use it later. So what I can do is kind of, copy and paste this. So what I'm going to do is I'm going to steal this. Now I'm going to make it a do while. So I'm going to put do here. And of course, just to make it look nice, I'm going to indent. Okay. And then I'm going to take this same while here and I'm going to put it at the end. Okay. So I'm going to do something like that. So this looks a lot shorter because look, you had this many lines before. You had to do the question, take it in, and then you had to do it again, right? With the while loop, because now you know it's a negative number. But with the do while, you're asking for the test scores, and it's going to happen the first time because, and I need to put, my curly brace in. Okay, it's going to happen from this curly brace to this curly brace the first time, and then it's going to check to see if it's less than 0, and if it's less than 0, it's going to do it again. It's going to go back to the start of the curly brace and do it again. But it's only going to do it again if this is true. If this is false, it won't do it again. But the do while happens one time at least. But do you see the difference is I can't actually cater this message to say they entered a negative value because I don't know that. Because the first time it might just go through one time and that's it. It might go through 2 times, but it's the same loop. So I can't change it because I don't want to say they entered a negative value the first time they did it because they might not have. But I can say here like this, I can say, if you wanted to, you could just say, do not enter negative values if you wanted to do something like that. Okay, so that's acceptable and that might work to cut down on the code. Okay, so this does the same thing. So See, it's not going to let you enter a negative value. And I didn't test that the first time, but it does the same thing. So if I enter, I'm just going to enter 2 so you don't have to watch me enter a bunch of scores. But do you see how it asks? It says here, do not enter a negative value. So you get that logic, but you can see the difference. Does everybody see this is the same as this, just a little, everybody's a little different and thinks a little different. I like the do while because it cuts down on your code. Your book likes to do the while like this. Everybody's different though, because you can actually change your message in here. So maybe that's why the author likes to do it this way. See, everybody codes a little different. I would have done it this way. Everybody with me? Okay, so do anybody have questions about that, how that works? Because I do want you to understand that. I know that's way back in loops, but when you're going through, I do want you to understand, like, why would you use a for loop versus a while loop versus a do while loop? That is something that you should be aware of. And I don't use a for loop for this type of situation because a for loop is best used when you know how many times you want to do something, okay? A while loop and a do while are used when you don't know how many times you want to do it. So in this case, I don't know how many times they're going to enter a negative number, and I have to keep doing the message that tells them, you know, enter another number. So I need to use that because a for loop would be if I knew how many times they were going to do that. Okay, so what this does is it actually is going to allocate an array based on the number that you do enter. So once you do get a number of test scores that's not less than 0, it's going to set up an array, allocate an array of that size. Okay, and then this is going to fill it with test scores. When you get to enter the test scores. Okay, and the same thing, you could change this to do while if you wanted to, but it's not going to let you enter a negative test score. Okay, so that's the logic for that. I do want to go down here to the actual sort. So it's going to actually sort them. So you notice that I do it and type in some numbers. Let's do 4. Let's do 90, 70, 60, and let's say 80. Okay. See how they're in order? Okay, so it does sort them in order. So that's what this does here. This is that selection sort that you have here. So I wanted to go over this with you because I think it's a good problem solving activity. And it's also good to not have code that you have no idea what it does, right? So I wanted to kind of cover this with you. If I can change this over here. Okay, we can get some more space. I want to put this here and give us enough space here that we can work with. So I want to go through this with you. So basically what's happening is you have a variable called start scan, okay? And you're starting at 0 because you have this loop here. See the start scan variable here? Are you with me? Start scan is set at 0, okay? Okay. And so I have start scan at 0. And then I'm going to have start scan is less than the size minus 1. The size is the size of the array. So let's say, just to make this nice and easy, we're going to see that we have 3 values, 90, 70, and 60. 90, 70, and 60. We'll say we just have those 3 temperatures, okay? Just to make it nice and easy. Okay, so those are the 3 values. So we're going to see that the size is 3 because there's 3 values. So the size coming in is 3. So we're going to see size minus 1, which is 2. So as long as start scan, which is 0, is less than 2, which it is, we're going to go ahead and do it. And then this actually tells us that do plus plus, okay? But we don't have to worry about that till we come back up. So then we're going to go down here inside the for loop. So we are going to go through the for loop because this is true. So we're going to set the min index at start scan. So start scan is what? Right here. 0, right? Okay. So we're going to start the min index at start scan, which is 0. And then we're going to set the min value at, now this is score index start scan. So start scan is 0. So that's score index 0. So what value do I have at score index 0? Does anybody know? 90. Good. 90. I didn't mean to start. Just have my finger there. I accidentally hit it. Okay, 90. So that's this first one. So remember that index 0 is 90. That's the first score of the array. Okay, so that's what this code is saying right here. Is everybody with me? Anybody have questions so far? Okay, then you get to this inner loop. Everybody loves inner loops, right? So you get to this inner loop, and the inner loop says, okay, this we're going to say is the outer loop here. And then this is the inner loop, okay? This is the index equals start scan plus 1. So index equals, and start scan was 0. So if I add 1 to it, it becomes 1, right? Okay, so index is 1. It says as long as index is less than size. The size is 3 because there's 3 values, right? So as long as 1 is less than 3, which it is, we're going to go through and do this if statement. Okay, the if statement says that if, and we're going to say if score index, so score index 1 is which value? 70, good job, is less than, now min value is 90, right? So is 70 less than 90? Yes. Okay, so then we're going to go through and we're going to say min value equals, we're going to take score index 1, which is 70. So min value becomes 70 and min index becomes the index, which is 1. Everybody with me? Okay, everybody's having so much fun, right? Okay, then we go back up here and we increment index. So index becomes 2, right? Then we check. 2 is less than the size, which is 3, true. So we have to do it again. So then we're going to go through this if, and we're going to say if, now this time score index is 2, so we're on 60. If 60 is less than min value, which is 70, is 60 less than 70? Yeah. Okay, good. So we are going to take min value and we're going to put the score index, which is 2, in there. So that's 60. And then we're going to take min index and we're going to make it 2, right? Everybody following so far? Okay, now we get up here and we increment index. So index becomes 3. 3 is not less than 3. So we stop this inner loop. Okay, so the next thing I have to do is go to this line right here. This one that says score min index. So score min index, what is min index? Min index is 2, right? This value right here. So score, this is after the loop, the inner loop. Score min index, so score min index is 2. So that would be score min index, and we're going to put score start scan. Okay, so score start scan is still 0, right? So we're going to take the score start scan, which is 0, 90, and we're going to put it in score index 2. Everybody with me? And then I'm going to take score start scan, which is 0. And I'm going to put min value in it. So min value is 60. Everybody see what just happened? So this happened to my array. I took and I put 60 here and I put 90 here. I switched values, right? I put 60 here and 90 here. It used to be 90, 70, 60. Now it's 60, 70, 90. They switched spots. So exciting. I could have. Okay. All right. Now, it just so happens that 70 is in the right spot. But what we're going to do next is we are going to go up to start scan. So when you're done with this, you're going to go back up and add 1 to start scan. Okay. And so start scan was 0. So now it's 1. Okay. And then we have to start all over again. We're going to do this because this is true. So we're going to go to min index, and min index is going to be start scan, which is 1. And then the min value is going to be score start scan. So start scan's 1, so it's going to be 70 because the index 1 is 70. Actually, yeah, 70. I'm going to look at this right now. Sorry. So 70. Okay. And then I'm going to go do my inner loop again. So I have to go back to my inner loop, and the inner loop says that, okay, so we have this index, right? Everybody okay so far? Yeah. Okay, so we have this index, and we are going to set index at start scan, which is 1 plus 1, which is 2, right? So if start scan is 1, we're going to add 1 to it, so it becomes 2. And 2 is less than 3 because I have 3 numbers in my array. So we're going to go ahead and do this inner loop. Okay. And then we're going to do the if. So the if is going to say, okay, no, I'll leave it on there. If score index, so index is 2. So score 90 is less than score min value. Min value is 70. So if 90 is less than 70, 90 less than 70? No. Okay. So then we're going to skip this condition because it's not true. Okay. And we're going to come down here. We're going to say if score index min index, which is 1, if score index 1, actually not if, but score index 1 will be 70. Okay, because that's what score start scan is, because score start scan is the score index 1, so it puts 70 in there. And then score start scan, which is 1, equals 70 again. Okay. So it didn't move anything in that case because it was already in order. If they were out of order, then it have to move them again, but the if didn't happen, so it just left it where it was. So then it goes back up, and when it increments index this time, start scan becomes 1 more, it becomes 2. And when I take 3 minus 1, I get 2, and so 2 is not less than 2, so I don't do it again. So I know I can stop, because when start scan gets incremented to 2, then this is not true anymore, and it stops this whole loop. Okay, so that's my stopping point here. When start scan increments to 2 here, this is not true, and that stops this whole thing. Okay, so I wanted to kind of explain that to you, because I know we talked about the selection sort, but I didn't actually go through it in detail. I talked more about the bubble sort, but there's this example that I want to show you with pointers that is kind of interesting. If you're going to go on to more advanced classes, you'll work with it again. But does anybody have any questions about that? I know that was kind of a long explanation for that, but okay. Okay. There was a reason for showing you all of that, because I know that that didn't have anything to do really with pointers like we were talking about, but I am going to show you pointers in just a second. So we went through this sort, and we went through this program where it actually finds the average and puts them in order. But there was a reason for that, because I wanted to show you this program here. So in your book, there's a program that it goes through in detail. And that's this program here. Okay. And so move this again so you can see it. Okay, so it goes through a case study at the end of the chapter and talks about donations to the United Cause. And what it's going to have is a list of donations. Okay, so it has an array of donations, and it talks about how can you sort this array without actually changing the values in the array, without actually moving them, because when I just showed you that selection sort that we just talked about with the temperatures, it actually did change the numbers in the array. So when I asked it to print the array, they actually changed the numbers. But what if you had an array and you didn't want to switch the numbers? You actually just wanted to order them, but you wanted to leave it in the order that it originally was in? You can use pointers to do that. So what you would actually do, instead of actually adjusting the values that are in the array and actually manipulating the original array, you can actually change what the pointer is pointing to in the order in which it should point to get it in the right order. Okay, so you're not actually changing the values of this. You would actually just point to the order so that you get it in order, and then you wouldn't have to worry about, changing the original array in that case. So you have to have, and if you wanted to do that, you're going to have an array with the numbers, and then you're going to have a pointer to that array. Okay. And so what it does, this should look very similar. So when you go to this function I have here, array selection sort, okay, here is going to pass in, and here you have a pointer to the array, and then you're working with, this is the same code that you just saw, except using pointers. So if the code that you just saw made sense when we went through step by step, this is the same thing except the pointer version of it. Okay, so what does that do? It actually is sorting them, but it's sorting the pointer to the value, so that when you're all done, the original array is not modified. It's just the pointer pointing to the actual array. So what that means is when you run it, let me just show you and then we can go back to the code. You have this donation sorted, and then these are you still have the original array you can print off in its original order. So see how this one's not sorted? So it didn't affect the array. So when you go to print it, it's still the original array. So when you show the array, it's actually fine. But then when you do the pointer array, that's the one that's actually sorted. So if you ever need to leave an array, its original order, but you want to sort it, you can actually have pointers that resort the pointers instead of sorting the array. Does that make sense, everybody? So if you look at this code, this should look like what we just had, except dealing with pointers to it. Okay. So if you look at the diagram in your book, you can see that it has, see if I can try and bring up, hold on just a second. See if I can try and bring it up here. We have course materials. Let's see if I can quickly do it. Otherwise, I'll just say everybody's going to go look at that later, right?
Yeah.
Okay, let me see if I can find it quickly. It's the example at the end of the chapter, and it has a nice little diagram there that has it sorted. By the way, if your Revel isn't updating your scores, please let me know so I can look into it. Okay, so when I look at pointers, it should be the last case study. It should be this case study. So here's the donations, and then here is the what it's trying to do, and here's what it does to get it sorted. So it starts it with the array and the pointer, and then this is what happens. This is the array. It's not trying to actually sort the donations array. It's just trying to point to the value to actually, when you go through the pointer array, that you'll get them in the right order. Everybody, does that make sense, everybody? Okay. All right. So I think that's all the examples that I had for you, but I wanted to have you answer some questions for me. That's going to help me to see what we need to work some more on, hopefully. So what I want you to do is take about 10 minutes or so. We'll see when everyone's done, and see if you can just open up Notepad and write down the answers to these. Pretend that this is a miniature quiz and you're trying to answer these, and we'll see how many you get right and what questions you might have about this. Okay, so try and do this for the next 10 minutes. And while you're doing that, I'm going to go ahead and take attendance, but I'm going to leave this up there for you. Let me see. I don't know. I guess never mind. I'll wait to do attendance because I can't do it with a Zoom. Because I don't think it'll. If y'all, can y'all take a picture of it on Zoom? I'm going to end this recording.